So G484 homework booklet question 7. Part A starts pretty straightforwardly. It's trying to get you just to remember those definitions of latent heat of fusion, latent heat of vaporization, but we have got the pencil mark there, making it clear they want these terms spelled correctly. So the key terms thereafter here were fusion, F-U-S-I-O-N, and vaporization, V-A-P-O-R-I-S-A-T-I-O-N, without a U. They do accept either a S or a Z, and certainly no intention of getting involved in an argument over which is American or not. With an S or with a Z, either were accepted. Part B then moves on fairly straightforwardly to start with a specific heat capacity question. Yep, I'll let you read that, but essentially we're doing M, the mass which you're given, C, the specific heat capacity given, delta theta, you're given all the information for 118 degrees. That works out there. So straightforward, if I'm totally honest, not entirely sure why that was given 2 marks. Two different reasons why the actual energy required to warm the water to 100 degrees is greater than that estimated. Well, really good example here, an illustration here of being really specific when you're trying to talk about energy losses. It's dead easy to say some energy is lost. That's not going to get you any marks. So where does that heat energy go? Well, some is used to heat the kettle, and some will be lost to the surroundings, to the air. It would perhaps be an even better, more specific answer. There was a third possible answer there, which was that some energy was used in boiling the water between the time when the water reaches 100 degrees and the kettle does the automatic switching off. Then part 3 is going back again, B part 3 is going back again to kilowatt hours, to G482 synoptic work. So it's asking you to calculate in kilowatt hours the average energy wasted per household by boiling too much water. So we start off by taking that figure of the amount of energy that's wasted each day that we've calculated and simply multiplying that number up, the 2.8 times 10 to the 5 by 365, to work out the energy lost over the whole year. Now if we're going to work out how many kilowatt hours that is, we need to know how many joules in a kilowatt hour. You may simply know that as 3.6 times 10 to the 6. That figure is often accepted as a definition of the kilowatt hour, in fact. Or you can simply think of it as we've got 1 kilowatt, 1000 in an hour, for 1 hour, 60 times 60, 3600 seconds. So we end up with the kilowatt hour is 3.6 times 10 to the 6 joules. So that energy loss that we have, if we want it in kilowatt hours, 365 times the daily amount. So that's that bit there, the total energy loss divided by the 3.6 times 10 to the 6, and it works out as around 28 kilowatt hours. So that's G484 homework booklet question 7.